Welcome again to the Advantech technical training. We will continue with the second part of the Common Field Site Device introduction. Now, we will introduce you the devices that are more commonly used in automation fields such as electrical and control cabinets, PLC, HMI, power generation, controllers CNC. The electrical cabinet. It has the function of support for mounting electrical or electronic equipment such as switches, measurement elements, displays, etc. Protect the contents from the environment such as water, dust, corrosion, etc. Prevent electrical shock to the operators during their work. The electrical cabinets are manufactured with different materials: stainless steel, aluminum, polycarbonate, fiberglass. Its performance is based on the IEC 60529 standard that classifies the ingress protection rating, IP codes, of this cabinets. This standard IEC 60529 classifies the degrees of protection provided against the intrusion of solid objects and water in electrical cabinets. The standard aims to provide users more detailed information than vague marketing terms such as waterproof. Ratings are defined by the letters IP followed by 2 digits. The first digit is related to the protection against ingress of solids. The number indicate conformity with the conditions summarized in the tables below. For instance, the number 0 means there is no protection, and the number 6 means protection against the ingress of dust tight. For example, an electrical cabinet rated with IP2X is protected against a solid greater 12.5 mm diameter which can be fingers and they will not be damaged. The second digit is related to the protection against ingress of water. The number indicate conformity with the conditions summarized in the table below. Thus, the number 0 means there is no protection, and the number 7 means protection against submersion at 1 m depth. For example, a cellular phone rated at IP67 is dust resistant and can be immersed in 1 m meters of water for up to 30 minutes. Electrical control panels are designed for mounting control mechanical equipment. Usually the design of a cabinet starts with 1. Incoming protection and switching. 2. Power and energy monitoring and control. 3. Power distribution system. 4. Thermal management. 5. Motion and drivers. 6. Circuit and load protection. 5. Motor control. 8. Enclosures. 9. Power supplies and transformers. 10. Programmable controllers. 11. Operator dialog. 12. Interface and I/O. 13. Machine safety. 14. Relays. External elements of an electrical cabinet. 1. HMI panels is a graphical interface that allows information exchange and communication between machines and the operator. 2. A push-button switch allows to turn on and off a machine. When it's on, a small metal spring inside makes contact with 2 wires, allowing electricity to flow. 3. Maintained push buttons. They require to be pushed once and can keep the stay until is pushed them. 4. Emergency stop switch is a safety mechanism used to shut off machinery in an emergency situation. 5. Tower lights, shows the state of a process alerting that some process happening. Internal elements of an electrical cabinet. Inside a cabinet, can be found several electrical devices. Some of them are introduced as follows. 1. transformers. They are used to convert one AC voltage to another AC voltage. Most popularly would be converting 480 volts AC to 120 volts AC for creating control power. 2. Programmable Logic Controller (PLC) is the brain of the control panel. It reads inputs and trigger outputs, then adjusts the outputs of the control panel. 3. DC power supply converts AC or DC to a DC voltage. Most commonly converts 120 volts AC to 24 volts DC. 4. Ethernet switch is used for connecting the devices such as PLCs, HMIs, and integrate them into the same network. 5. Circuit breaker protects loads from pulling too much current and help to prevent a possible damage to the whole system. 6. Disconnect switch. It will usually disconnect all electrical power from the control panel. 7. Wire duct is usually ran around the perimeter of the panel and in between rows of electrical components. Wire duct house the wires that interconnect the electrical components. 8. Terminal blocks are connection points to tie wires together. Some are for internal connections and some are for connecting field components to terminal blocks. 9. Breakout boards are specialized terminal blocks that can be used to simplify wiring of components that have connectors that would normally need soldering. 10. Fuses are like circuit breakers and protect loads from pulling too much current but are only good for one use, cannot be reused. 11. Relays is an electronically or magnetically operated switch. Power is applied to the coil, and it switches the relay contacts. As a result, the contact that was open at the beginning will change the status, and turn to be closed. 12. DIN rail is a metal rail that allows the mounting of many industrial control components. 13. Overload protects loads, usually motors, from pulling more current than the overload. 14. Contactor is the same as a relay but is usually larger in size and used for a 3-phases motor. An application of this is a motor starter, which helps to switch the power automatically or manually to a motor and at the same time protect the motor from overload or faults. A programmable logic controller, PLC, is a computer designed to work in an industrial environment. It continuously monitors the status of devices connected as inputs. Based upon a user-written program, stored in the memory, it controls the status of the devices connected in the output. PLCs are used in many machines, in many industries. Typically employed in industrial electromechanical processes, such as control of machinery on factory assembly lines, amusement rides, or light fixtures. The PLC mainly has 5 parts: input module, output module, CPU, and power supply. The primary function of a PLC's input circuitry is to convert the signals provided by these various switches and sensors into logic signals that can be used by the CPU. The CPU evaluates the status of inputs, outputs, and other variables as it executes a stored program. The CPU then sends signals to update the status of outputs. This picture shows a very typical application architecture in a smart oil field. In the PLC, inputs will have connected sensors such as thermometers, flow meters, pressure sensors, and etc. In the PLC outputs, it will have connected lights, electric valves, motors, and other actuators. The PLC reads the inputs and evaluates these values in the program that is stored inside of the CPU, then the PLC updates the status of the outputs. At the final, all of the information can be transferred remotely to the control room where is monitored and analyzed. Day by day, many companies are leading to advanced technologies in the development of new controllers (PLC). Every company will provide various and different functions and features. The most famous PLC brands around the world are Allen Bradley, Schneider, Mitsubishi, Omron, Siemens, Bosch, ABB, Hitachi, Honeywell, Delta, Faytech, and General Electric. According to the application, we can find PLC dedicated for basic applications with smart relays such as Siemens Logo series, Schneider Zelio series, and Omron Zen series. For simple machines application, we can find Delta DVP series, Schneider Twido series, Siemens S7 series, and Allen Bradley Micrologics. On the other hand, for more complex applications with middle number of inputs and outputs, we can find controllers such as Schneider M340 series, Siemens S7 series, and Allen Bradley Compact Logics series. Finally, for critical applications that requires high number of inputs and outputs and redundancy, we can find Schneider Premium series and Siemens S7 400 series. Another important device within an automated system is the HMI, that states for Human-Machine Interface. Before the HMI came into existence, a control might consist of hundreds of push buttons and LEDs performing different operations. HMI is a device for user interface or dashboard that connects the operator with the whole system. The HMI provides a visual representation of a control system and provides real-time data acquisition. It is a centralized control center that is user-friendly. It is suitable for applications that require constant feedback and monitoring. In the first picture, it shows an application where the HMI is installed on a cabinet. The pre-assembled seals allow high IP protection against water and dust without big effort. In this way, the panel can be manipulated without a risk of damage. In the second picture is the installation seen from inside of the cabinet. The system as a whole can then be fixed with 8 screws from the inside or with clamping screws versus the front panel. This design type features extreme robustness and is particularly suitable for quick installation. This is an application of a manufacturing line monitoring system, which allows the operators to monitor everything on the factory from a centralized room. The Industry 4.0 solution enables operators to acquire data at different stages and stations of production. In this application, every station contains different sensors such as switches, light towels, and analog signals. The PLC takes all this information from the sensors and transforms it to digital signal, so the HMI can decipher, make decisions and show the results on the screen. The advantage of developing in smart factory is that operators can predict machine failures and brings higher operational intelligence. Finally, it is possible to connect multiple production lines and machines with each other. Now, we will give a general concept about electricity. Electricity is nothing but the movement of electrons through a conductor, like a wire. In the below picture you can see how does the electricity flows in two ways, either in direct current, DC, or in an alternating current, AC. The difference between AC and DC lies in the direction in which the electrons flow. In DC, the electrons flow in a single direction, or forward. In AC, electrons switch directions, sometimes going forward and then going backward. The advantage of using alternating current AC is that it can transmit electricity over large distances such as for household use. Converter and inverter are two concepts that are easily confused, however we will make a comparison between the two. The converter is an electrical device that converts the voltage from alternating current, AC, to direct current, DC. The converters are fundamental part of most of the electronic devices. The inverter does the opposite work. It converts the voltage from direct current, DC, to alternating current, AC. The below application starts with the solar panels collecting the light from the sun. The circuit of the solar panel is coupled to the inverter that converts the DC current into AC. Later this energy can be used in a house to turn on the lights. Now we will also explain the difference between a motor and a generator. The motor converts electrical energy into mechanical energy. For this, it uses electricity to work. The motors are used for pumping water, automotive, conveyors and lifting. In the below application, the motor is coupled to a pump to extract the water from the river, and provide the house with water. On the other hand, a generator converts mechanical energy to electrical energy. Thus, this device generates electricity. They are usually used for applications where there is a lack of energy. In the below application, the garage may be located far from the house and with no electric installations. The portable generation can be employed to turn on the motors, and open the doors and let the car get inside. Combination of AC motor with inverter. Homes, office buildings, and factories are supplied with AC electricity at various frequencies and voltages such as 50 Hz and 60 Hz. But AC motors are constant speed devices. So, how can we modify the motor's speed according to our applications? In the electrical field, we can take advantage of the inverter. It will change the input voltage or frequency, which directly modifies the motor's rotation. Without an inverter, the AC motor would operate at full speed as soon as the power supply was turned on. With no change of speed, applications would be limited. This type of control, in which the frequency and voltage are freely set, is called pulse width modulation, or PWM. The inverter first converts the input AC power to DC power. The second step, the inverter creates a new AC power using PWM control. At the final, the inverter provides to the motor a controlled power that suits any application. Finally, we will talk about the controllers CNC because nowadays are widely spread in the industry. CNC machining is a process used in the manufacturing sector that involves the use of computers to control machines, tools such as lathes, mills, routers, and grinders. The physical movements of the machine are controlled by instructions, such as coordinate positions that are generated using a computer. CNC is typically used to refer to a device which uses a rotating cutting tool which moves in 3 or more axes, X, Y, and Z, to cut out or carve parts in different types of materials. The advantages of using a CNC are high repeatability and precision, high volume of production, machining of complex contour surfaces, more safe, higher productivity with higher quality. But it also has some disadvantages such as costly setup and difficult maintenance, requirement of hiring skilled operators to program the computers. Here, we introduce the most representative CNC machines. Milling, most widely used CNC machines, predominantly for drilling and turning metals. Lathes, for production of 3D shapes or molds. Routers, used for cutting complex or intricate shapes and prototypes. Plasma and laser cutters, utilized for cutting 2D shapes and molds. Web Access CNC Advantech solution. With the evolution of industrial automation, machines nowadays are becoming smarter and more digitized. To accelerate the implementation of smart machine monitoring and management in Industry 4.0 applications, Advantech's CNC machine management solution plays a critical role in IoT integration from edge computing to cloud-based services. A solution of this type starts connecting the instrumented module and equipment that is located in the field site. Later the information is transferred to the WisePass cloud service using the edge devices that work as a gateway. As a result, Advantech offers an intelligent CNC management solution has been developed to bridge the gap from traditional machine management to optimization. Thanks for watching this training video. You are welcome to keep watching the next one.